Hello world, it's Angelat. Just kicking it, drinking some coffee, and gonna prototype with my leap motion. So this little gadget is this sweet. It's not quite a camera, but it can detect your fingers and your hand, and you can use that detection to create apps that respond to your fingers and hand. Basically, it's gonna, I think, be an awesome new form of input that'll change the way that we interact with our computers, especially once they start embedding them in computers. And I guess they go on sale in Best Buy soon. And I don't know, it's a nice little device. So we're going to use Tributary to play with it. And I want to do a little bit different, something a little different today. A lot of times I've been building stuff from scratch for these. And what I want to do here is use a couple pre-made tributaries that will get us going, because really what I've done, I'll show you here, is the Leap sends off little data packets on the WebSocket over a WebSocket, and I took something from Leap and I listened to that WebSocket, and then I wrapped up some stuff for tributaries so that we can basically, like in our main code, listen on some events, just really simply like the frame event, where we can see see the data coming, and if it opens and closes, because I can turn it on here, and I use my hand here. I point one finger. You see the numbers here changing. Let's see, up is Y is going up, it's like 300, stuck there at 300. Going down is like 100. So you want to be able to listen on that, see what this data is. Let me pause this for a second. We'll open the console. I'm console logging each of these frames. We have hands, we have pointables. Pointables is like the fingers is detecting. We have direction, the position of the tip of your finger, the velocity, all kinds of information is coming out here. For your hands, we got, I had one, I was using one hand, you can use two. Let me show that real quick. Yeah, 1 second. You have the palm normal, which is like the direction of your palm, like where your palm is, the velocity, how fast it's moving, and some other stuff. I mean, there's plenty here. I'm going to put this link for this basic HUD so you can just explore in the link to this video. But now you see I have two hands, and I can, the normal is changing, positions. I'm showing like the max Y, so right now like my hands are low, it's like at 100. You go up here and they're about like 4. This one's at 400. So you can kind of get a sense for like the coordinate system that the Leap is using, right? Now what I want to do for today's tributary is take this other example that I've got, which is this excellent project from a couple guys here. You can see the link. It's called Flat Surface Shader, and basically if you play it, it allows you to do this lighting on these canvas elements, and it's pretty fast, and it looks sweet. Cool demo. Basically, they have this GitHub repo, so it's open source. They have some examples. I wanted to play with it, so I pulled their main example into Tributary, and you can do stuff like we can play with maybe the number of lights. So now if I put it here, there's a ton of lights going around. That makes less sense as a whole number, or more sense as a whole number. The Z offset, if we make this a lot bigger, the light's sort of brighter, make it a lot smaller, it's wider and narrower. So I want to play with these things, and also notice how I'm moving the mouse around, and the light is following the mouse, right? So this would be a fun thing to do with the Leap, to kind of get a feeling for it. Would be if I can move my hand around, and instead of the mouse, the little lights would follow my hand, and if I move it up and down, I want the light to get brighter and less bright, right? It's a pretty straightforward kind of application, and it shouldn't take us long, so I'm going to show you how I do it.
Kane is in the building.
I'm going to scroll down to the bottom here. I already happen to know where the mouse stuff is, right? So I'm going to go ahead and comment this out. And I'm going to pause it so that it keeps moving around. What I'm going to want to do though is make a function like on loop, and I'm going to want to change this instead of the X and Y of the event for my mouse. I'm going to define some X. Let's just do it hard coded right now. Define this X and this Y, and what we're going to do is we're going to get that from the loop. And let's see if we call it. See, it doesn't. Why that could be. Well, we can find out. Weird. Oh, probably because we're calling it before it's in the difference. So yeah. Oh, we're not doing this. So yeah, so that should set it to that point, and if we make this, so the light starts here and then it will like move to wherever I'm putting it. So if I make this like 300, it should come to right there, right? I can make this 400, it should come out, settle around here. So this is like, wherever this point is where these lights kind of congregate around. So now we want to get these X and Y from our loop. So instead of calling this, with some constant or whatever, we're going to pause this. And I'm going to go over to this HUD tab. Also here at the bottom, we're just going to take that function. Oops, actually, yeah, we are going to take that. We are going to replace this. It's not console yet, it. Of course, we have to provide the loop stuff. Excuse me, so let's do that. Let's call this loop.js. Just copy everything from here, and it'll know exactly what it does. Just for now, I will be replacing this kind of example with loop.js from loopmotion fairly soon. But to get going, this gives you access to basic data. When you want to use the gestures and stuff like that, you want to use the official API. And so I'll be getting into that, and I'll share it when I do. But let's for now get our loop here, and we can see. Remember the console here. We have these objects. So let's look at those things. What we want to do is grab the hand position, and we're going to get the palm position. You're going to get the 0 is X, so X goes like left and right, Y goes up and down, and Z goes in and out. So we're going to go left and right and in and out as if our hand is on top of this thing, so the light is following us in that plane. So what I'm going to do here is I'm going to check to make sure that b.hands exists, and I'm also going to check for b.hands 0. So I'm only ever going to do this update if those things are true. And let's see, I had d.hands at 0, palm position. So let's do this, d.hands 0, palm position. And So we can use any of the other attributes. We can use the pointer, the first pointer, if you want to like use your finger to do it. I'm just gonna stick with the hand. It's pretty simple to control like this. And the X is gonna be 0. And instead of Y here, well, the Y is actually gonna be the Z in loop terminology. So I'm gonna get the number 2 in there, which is the third element of the array. Oops, I'm sorry. It's still the first hand, the only hand we care about is the hand, but the third coordinate of the palm position. Now that will give us, that will do something. Let's see what it does. We can move our hand, but it's only moving in this little spot right on the top left corner. Now that is because, let's see here, if we play this and we look at our hand position, right, X goes from negative 100 to about 100, and Z goes from, we're like at like 150 to negative 100. My hand's like all the way out here, so I can get to like 150 is back here, negative 100 there. Get out to 180, 150, you know, out there, to about 200. So it's like negative 200, 200. So we need to kind of scale our stuff here. So if I do, I can do like, for instance, X scale, and I'll make the domain for X scale be negative 200 to 200. And I'll make the range for this be, let's spell it, the width of the screen, because tributary SW is the screen width. It's a sort of convenience variable that's always prepared for us no matter what size the browser window is. And this, we said, that went from like negative, let's see, Z went from 150 is back here to about 100. So we want to go, yeah, so, I'm sorry, negative 100 to 150. And we'll do that from 0 to tributary that's passage. So we can actually do X scale X. And I think we can just do Y scale as well. Let's see what happens here. Oh, not an error. Let's see what it's telling us. Syntax error. Unexpected identifier. Oh yeah, I need a equal sign. So now, if I put Z, it goes down. So I kind of want to flip the Z, because this is, as I push in, it goes down. I kind of want it to do the opposite. And the X, I'm out here. Yeah, it seems, you know. So yeah, let's flip this. This is easy to flip. You can just, so now as I go forward, it goes up, back goes down. So if I, that's on myself, right? Follows my hand. Cool. So that's cool. Let's make the light change as I go up and down. So up and down is the Y value, right? So well, it's Y value, but let's do it like this. We're gonna call it Z. One, and then we can use that light. We can just change this Z offset, and that one's equal to 100. But let's change it by the Z here, or the Y here. So the Y here goes from, if we go down here, we're at 100. If we go up here, we're at 400 about. So we go. Let's make a Z scale too. So that goes from about 100 to 400, let's say. And let's make the range something like 20, say 400, I don't know. See how that looks. Z squared Z. So as we go up, it gets brighter, move it around, lower. There we go. Kind of holding it weird. Yeah. So there you have it. Let me fork this. And I'll be out. Peace.